let's say you do want to remove things while iterating it. How would you do that? So that's a pretty good question. So let's say I want to make a list all. So if I have even elements, I want to return all the odd elements. So we obviously need to remove all the odd elements. Okay, so if we want to do that, what you have to do is you have to make a copy of the list, and there are many ways you can make a copy of the list. So one way to do it is to just call a method called list.copy. You can also do list of list. So this basically makes a copy of the list. Or you can do something that I like to do a lot. You can just slice it from 0 to the end. So this slices the entire list. Okay. So since we are talking about methods, I'm just going to use list.copy. Okay. And now what you want to do is you want to basically take every item in the copied list, and then if it's the case that that item is an even number, you want to go into your original list and remove that item. So this way, you're removing it from another list while you're iterating through a copy of that list. So this prevents things from going crazy. And then at the end, if needed be, you can always return the list. So you want to return the list because that's what you that's what you're modifying. Okay, so let's make sure this works. We're gonna do doc tests on this, and it works. So whenever you want to iterate and remove something through a list, always make a copy of the list, iterate through the copy, and then modify the original. So that's the general formula for that. Okay, now I'm going to give you a pop quiz out of nowhere. So let's see if you remembered the stuff I talked about a little in the previous slide. Say I execute the following statement. List 1 is equal to 246, and I bind list 2 to list 1.append of 8. Okay? So what happens to, what is the new list 1 and list 2? So take some time to think about this. I'm going to spoil the answer in 3, 2, 1. So list 1 turns out to be 2468, which is pretty intuitive because we just added an 8 to the list 1. But list 2 is a little weird because if you print out the elements of list 2 after executing this, we see that it's none. And why is that true? Well, remember from the previous slide that append always returns none. So what we really did is this entire expression returned none. So list 2 was bound to none. That's why when you print out list 2, you get none. So this is a very important concept, and this is a common misconception when you work with list methods. So make sure you understand this. The next thing we're going to talk about is string methods, because strings are also objects and they have methods. And they actually have so many methods that there are too many to show on this slide. And if you want a full description of string methods, some of them are really weird, some of them I don't even understand. But if you're really interested in that, go into the Python documents. I'll leave a description of that I'll leave it in the description. Alright, but I do want to show you some string methods, so just so we can see an example of how that works. So let's say I make a string called hello world. And let's say I want to capitalize this string. I can use a method called string.upper. And it returns a capitalized version of it. Now let's say I only want to capitalize the first letter of the string. How do I do that? I just do string.capitalize. I can use this method. And we get the H capitalized. Okay. So notice that this doesn't actually mutate the string. So our original string is still hello world. So this doesn't mutate, it just returns a new one. So important idea to remember. Now, let's say I want to split this string up into separate words. So how do I do that? So what I can do is use this very handy method called split. And it returns a list of the word split. And if you remember from the very, very first video, in the Shakespeare example, when I was going through that long text document, I wanted to get each individual word right, and the way I did that was to split it up. So this is very useful if you want to go through a text file and get all the words. Anyway, that's so the next thing I want to talk about is then going to be the box and pointer diagram, which is a very, very important concept when you want to understand exactly how lists work. So the best way to demonstrate this is to go into Python Tutor and look at some examples. So when we define a list, remember a list is an object as we just learned. So what's going to happen is we're going to make an object pointing to 2, 4, 6. So this is what a list looks like as an object. And then when we pop an element, we're going to remove the last element. And then when we concatenate, basically, our 1, 2, 3, 4 with this list, we're going to add elements to that list. And then when we create a nested list, the nested list structure is very interesting because how many elements does this nested list have? It has 2 elements. And then each of those elements then point to another list. So the way this looks is that the list 2 is pointing to a 2-element list. But the 0th index of that is pointing to another 2-element list. So this points to this list right there. And this list, hold on, so this list right here is at the first index is then pointed to this list. So nested diagrams can be a little confusing, so make sure you understand how this works. It's all about pointers at the end of the day. We're pointing to lists in the object memory. Alright, let's look at another example just so we can make sure we understand that. Let's say I define another list, and then I append 10, I'm going to get that into the 4th index. And now I'm going to add a nested list to this. So what does a nested list look like? Well, in this nested list is only 1 element long, but then the 0th index of that points to another list, 5, 6. So that we're going to so the 5th index is going to be point to a list 5, 6. So that's the key idea here. And if we append another nested list, this nested list is interesting because it's a 1-element list that points to another 1-element list. So if we look at that, we have a 1-element list right here. Okay, so this is then pointing to this 1 element is pointing to a 1-element list which contains 11. So this is the big idea of nested lists. So nested lists can be quite confusing, so make sure you go through several examples and see how those work. Alright, that's all I have for today. I hope you enjoyed this video, and I'll see you next time.